Malaria remains a significant disease globally. And over the past recent years, because of the global pandemic, there's been a massive uptick in cases and deaths worldwide. My research is focused on a specific type of cell called a T follicular helper cell that activates the immune response to develop antibodies. My team has discovered the specific types of cells that drive antibodies in malaria and shown that age is a really important factor in how these cells work. This has got implications for vaccines because we know how we can target the right type of cells to boost responses, and we know we need to think about the different age of the populations. So in adults, you have a really robust activation of these cells that drive antibodies, and in children, this activation seems to be suboptimal. What that means is when we think about vaccines for children, we might need to think about different ways of activating these cells or understanding why these cells aren't activated during a malaria infection. With the CSL Centenary Fellowship, I'm going to be working with international collaborations to gain access to tissues from the spleen and the tonsils from children and adults in malaria endemic areas who are having these tissues removed for other reasons. And that is going to allow us to really study how these cells function directly in the site where antibody development occurs. This project is going to be undertaken at the Burnett Institute, and we hope that this research will increase the protectiveness of vaccine, particularly in children who are most vulnerable from malaria infection. Ultimately, because these cells are essential not only for malaria antibodies and malaria vaccines, but also all antibody development, any approaches that we identify that boost these protective cells could be repurposed for other diseases.